Hello everyone, good evening.
Good evening, sir.
Good evening. So today um we'll cover week 1, 2 as a revision session.
Okay, sir.
Okay. Share my screen. Okay, so I'll start with week 1. So I'll go briefly about this, not in much detail. If you have some doubts, we'll always cover it. Okay. So statistics is a branch in which we collect data and then we try to describe it. So the task is we want to summarize it and then we want to draw some conclusion out of it. So that's why we have statistics, right? Um, so describe, analysis, and drawing conclusion using data is statistics. In statistics, we have two branches. One is descriptive statistics. So one is descriptive statistics and another is inferential statistics. So let's say I have a population. So population could be anything. Um, you want to describe data about, let's say, countries, India, USA, Germany, something. So that could become a population. Okay, so something you want to describe about any anything, right? So let's say it's about a drug test you want to do, then all the patients related to that disease. And if it's a car, then uh, let's say all the cars, right? Then something like that. So all could be a population. And then from that we take a small, uh, small portion of it and we call it as a sample. So sample is something which represent the population and we try to study this. So since population, collecting all the data about population is nearly impossible. It's very difficult. So we can take a small sample of it and then analyze it, okay, and study about it. So to study the sample, we need descriptive statistics, which will summarize it, right? Describe it, that what is it about, what is, mean of something, that's a median, mode, graphs and all. We'll plot that to describe the data of sample. Then main task was from sample is we wanted to draw some conclusion about the population, the whole population, right? Um, let's say this drug will work. Some new drug you want to invent. Will this drug work on all the people taking it? then you will try it on, let's say, sample. Then maybe you can figure it out, okay, it will work for all of them, right? So uh, something like that you can do. So that drawing conclusion is inferential statistics. But this course is a primary course. So in this course, we'll only discuss mostly about descriptive statistics only. And since you'll require probability for inferential statistics, which will be in upcoming weeks. So not in just 4 weeks, but after from week 5, it will start somewhat like permutation and all. Okay, the probabilities will be required to do the inferential statistics, and that's where we'll do it. Okay, after learning probability. So what is a population, and what is sample? We can see few examples about it. So uh, let's say, uh, so what is the task where this will come with? Let's say you wanted to see the percentage of all the students in India who have passed their class 12th exam and study engineering, right? So I mean these are the questions. Okay, so prices of all the houses in Tamil Nadu. Okay? The total sales of all the cars in India in the year 2019, right? So this all we are currently talking about population. I mean, like, who all the students, right? So you can see all the students in India who have passed their class 12th, then all houses in Tamil Nadu, then you can see all cars in India, right? The age distribution of people who visit a city mall in a particular month, right? So here all is not written, but this also we're talking about some kind of population. Okay, so that's what our interest, study of interest. But you can see that we can't collect all the students' data. Maybe all the houses data is nearly impossible, right? Then total sales of all the cars in India, let's say this data collecting could be difficult, right? So we then will make some samples out of it, right? We'll collect the samples from that. But these are the tasks we wanted to do, and that's why we need this thing, right? So population is the total collection of all the elements that we are interested in is called population, right? So all the all the elements. This is the main important key that we are interested in. All the elements we are interested in is called population, right? So here, if you can see houses in Tamil Nadu, let's say Tamil Nadu is a state, right? A state of India. So in that, all the houses are population, okay? And a subgroup. So when we take a subgroup of population that will be studied uh, in detail is called sample. So let's say all the houses are this in Tamil Nadu. Okay, so this is our population, and of course I can't go and collect all the houses data. Right, I'll take a sample of it, and which will be a subgroup of the population, right? So subgroup of population, yes, this is a subgroup of population, and that will become our sample. Okay, so why do we want to uh, do this statistical analysis? Purpose, what is the purpose? uh, Depends on that also. Like, let's say your study is uh, descriptive statistics, then you
Excuse me, sir.
yes.
Sorry to interrupt in the class. Sir, I have a little question.
Yes.
Will you discuss about week 3 theory also in this session?
No, that is tomorrow.
Only one on two.
Yes.
Okay. Thank you so much.
Okay, so let's see when we what is the purpose, and when should we use descriptive statistics, and when should we use, let's say, inferential statistics, right? So let's say if the purpose of our analysis is to examine and explore information for its own intrinsic interest, study is descriptive. Basically, I have some data. Okay, I have some data. Let's say rows and columns. You can say sheets and all. Then if I just study about it, summarize it, and study about this only, and don't make any conclusion out of it. That is called like something you can say intrinsic interest. then it will become descriptive study, right? If the information is obtained from a sample, so we'll take a sample, we'll make we'll obtain some information from that, uh, right? Uh, and then we'll draw conclusions about the population. So we have this population, we take a sample, we do study on this sample, and then we'll draw conclusion about population, right? So that is inferential type of study. Okay? A descriptive study may be performed either on a sample or on a population. Uh, okay, but inference you will make when you can't be able to collect the data, right? So inference is about chance, like you might miss something. Anything can happen, right? So I mean that's when inferences you make. I mean otherwise you don't need to make any inference. Okay, so that's why when when we have the whole data set, why do we make inference? We don't, right? So then we'll only do descriptive study. Okay, then we don't need inference study if you have the whole data, all the data you have. But generally we don't have, so we have sample of it. Okay, generally we have sample of it, and that's why we on sample we can do both descriptive as well as inferential. Okay. On on population we don't need inferential because we have the whole thing. Why should I make any assumption? Okay. Uh, then we can see what is okay. What is data? Okay, that's right. Mm, okay. So so data is just information, right? How did you collect it? So it could be structured and unstructured way, right? So structured is something you get in a rows and column manner, right? So let's say these rows are there, right? So this rows and then you have columns, various columns of that data. So this will make it uh, structured data that all the things are in a structured manner. You know what will come here, right? So let's say a column is gender, then you know that what could be written here, right? Let's say male written, female written, then you know that what does it mean, why it is related to gender and all, right? So that's why it's a structured kind of data. In unstructured data, we have anything, like we could have, let's say, song. um, if you collect that, comments on some social media, some textbooks are there, right? So written. So that all is a data, but that is not organized. So the organized data is structured, and which is unorganized way, right? Anything could be written, like hello, um, add 5 + 2 something. So anything can be written, and then that could become a data, but that is not structured. That is unstructured. So that there is no organization in that. Okay. Now let's see what is variable and cases in a structured data. So if I have uh, a case is from where we collect the data, the unit from which we collect the data. So uh, so let's say in our okay, um okay, let's say we have hospital. uh, this hospital is collecting data about the patients, right? So the patient goes to the hospital. It's a patient one goes to the hospital and they collect their temperature. Right? So they collect their temperature, they collect their, let's say, blood pressure, oxygen, and all, right? So this patient is a case, a unit from which data are collected. So this patient is from this data was collected, right? Then another patient can go and same thing they will collect, right? Same thing they will collect for patient two. Another patient, any number of patients can go, and this all patients are a unit from which data are collected, right? And this are variables. We are collecting temperature of the blood pressure, oxygen level, and all we are collecting. And so that is variable, right? That will change. So one patient could have temperature of, let's say, 99 Fahrenheit. Another could have 100 Fahrenheit. Uh, Another can come up and he has, like, 98 Fahrenheit, something. So it can range to some level, and It can be anything, right? So that's why it's called variable. And same will be other variables also, right? Um, so that that was about data, what is case and variable. Now um, we have okay. Uh, so we have this variables, right? Which are the columns. You can think of them as columns also. So we have this variables. So variables could be anything, right? They can be a numerical variable. They could be a categorical type of variable, right? So let's say numerical could be, just now we took temperature is a numerical thing. We write numbers, let's say blood pressure, oxygen, and something like that. So categorical could be name. We can write their name. We can have their gender, right? We can have their, let's say, location or place from their a patient belongs to, right? So this all can be categorical type of data, and you can see so all the qualitative type of variables are categorical data, and all the quantitative type of variables. So this temperature and all are quantity, right? You can measure them. Measuring units are there, right? This uh, makes them a numerical kind of data. Uh,
Sir,
yes,
sir, BP comes under which scale, sir? Which scale of measurement?
we'll go there.
Okay, sir.
Okay, so now we have, let's say, cross-sectional and time series data. So time series data is which we collect over time, right? Over a period of time where the time is very uh, included, right? Let's say you have uh, you know uh, meteorology or in weather data. It's weather data of a city. If you collect that, then then you can see, let's say, on date first of something, let's say first of 2024, we have this temperature, some temperature, right? You are measuring temperature of the city, right? So, and that's a wind speed you are measuring. Wind speed you are measuring. Okay? Then on second, uh, you measured it again. Okay, 3rd of January you measured it again. So you'll measure the same thing, like the variables are same. Variable, of course, they were same for other cases as well, but in this case, time is now changing, and we are measuring same thing, right? So on this day, temperature was, let's say, some amount, right? uh the 34 degrees centigrade, the 35 degrees centigrade, 28 degrees centigrade, could be anything. And wind speed also, you can have it in different ways, right? So that's how you will have different um, variables, and this is a time series data because data is recorded over time, right? uh, let's say you take a patient data, then what we are collecting is not time bounded, right? We don't even have anything related to time for a patient, right? So that kind of data is like, you can kind of think that the data was observed at same time. Okay. Okay. So this is another, let's say, example of time series data. So we have this potatoes, uh, let's say, sold in a market, right? So potatoes are sold, and we are collecting this variables, like quantity, cost of potatoes, and selling price on a particular day. So let's say 1st March, we so 0 kg means you can say maybe one less than 1 kg, and this much selling price was there. Then on 2nd of March, this much quantity sold, and cost was this, and selling price was this, right? Okay. And 3rd March, same thing. So you can have multiple uh, variables for same thing, potato, and you can collect it over a period of time, right? Over a period of days here. It could be hours, minutes, doesn't matter, but it is collected over time. Right? That's what makes it a time series data. Okay. Mm, uh, now now we'll
Uh,
see what is measurements of yes.
Excuse me, sir.
Yes.
Sir, as you said, we can say that, sir, if we measure um, under 24 hours, if we measure data under 24 hours, then it should be cross-sectional or
No, it's not like that. What kind of data it is, based on that you can decide. So it could be in seconds also, and it can become time series. Okay. So I'm not sure how sensitive your data is, but depends on the data. You can collect it hourly also. So even weather data comes in hourly also. Okay, let's say you have weather data which collects hourly. Let's say at uh, morning 6 a.m. this happened, 7 a.m. this happened, 8 a.m., 9 something, right? Same thing, temperature and wind, let's say they are wind speed they are measuring. Will collect
yeah,
same,
I
but
am asking.
for an hour. So this is also time series. It doesn't
Actually, I
matter.
am asking for this type of data as you have written now.
Yeah, this is a time series data.
Okay, sir, thank you.
Sir, if the weather is taken for the same day for different places, that is cross-sectional, right?
The same day, different places.
Yes,
The
sir.
sa-
Yeah,
Day is same, sir, and places is changed.
yes,
Cross-sectional
definitely.
data.
okay.
So yeah, it's about study. What kind of study you are doing? Like you are doing based on time. Is it uh, affecting time or not? So that's what makes it time series and cross section. Now let's see. We have scales of measurement. So first, let's say we have categorical data. Okay? And in categorical data, uh, we could have anything, right? Let's say gender, names, and all. So if we have that kind of categorical data, and we can't do anything, like what we can do, we can do count on them, right? So um, it's a it's called nominal data. Okay? Nominal data, where there is no order in between them, there is no interval or anything. So we just have this data. So you can see when the data for a variable consists of labels or names used to identify the character of an observation. The scale of measurement is called nominal. So basically, what we have is we have labels or names, but we are just identifying the characteristic of an observation, right? So say we are writing name of theirs, we are writing genders of the location from they are coming, uh, what job they are doing, something. So this all kind of things are nominal kind of data. And in this cases, we can't do much, but what we can do is we can count them. Okay? We can count them. Nothing else we can do, like not um, order them or adding them or something. So then comes the another data, which is ordinal kind of data, right? And ordinal data, you can see, like, let's say I have t-shirt sizes wore by people, right? So t-shirt sizes people are wearing, let's say S size, M size, L size, XL size, and if you don't know, but M is anybody have doubt?
No, somebody has unmuted the mic.
Okay. Okay. So let's say we have t-shirt sizes, and smallest S you can say is small, and that is small than like medium. There is an order in between. So M is there, then after that L size is bigger than M, then XL is bigger than L and all, right? So you have this kind of order. It could have more also, but for our case, for our example, we can take this 4 categories, and you can see there's order in between them, right? So what we can do in this case is that we can count them. Definitely, we can count them, right? That how many S size t-shirts were there in the data set, how many L size t-shirts were there in our data set, something. But we can order them also, right? So ordering and count, this both we can do in this. Now, we don't know what is the difference between S and M. We don't know like what could be the distance between them, right? What is the difference between them? I can't do L minus M will be something, right? That's not defined anyway, right? So then comes the interval data. Interval data says that okay, now what you can do is you can definitely count them. You can order them also, but there's another thing you can do now. There is a fixed interval between them. So these 2 points, whatever written here, let's say generally, the good example is let's say temperature, right? Temperature. So if we have, let's say, 30 degrees, and let's say we have 40 degrees, right? So we know that the distance is 10 degrees, right? Now we have exact distance within the interval is fixed, right? Let's say I have 10, and then let's say 12, right? So if I write this, then you know that this the interval is of 2, 2, right? Interval is of 2. So this interval is what makes it the interval scale of measurement, right? So if it's a okay, interval scale. Uh, uh, Hello, can you mute yourself? Okay. Yes. So now we have interval, right? So we can define interval in between them. We know the distance between 2 data points now, right? So that's what makes it uh interval data, right? So now we have um what you can see exact difference between them. You can say exact difference. We can now do this. So basically we can do so we had this count. We can do the ordering. Now we can do actually addition and subtraction. Addition and subtraction. Okay. But there's still one point is left, that we can't do them multiply or divide. The reason is because uh, there's no reference in this, right? So there's no true zero present in interval scale. So if you can see, let's say I have money, or let's say I have age, right? Age is there. So anyone who is born, he will have least is 0, right? He can't be less than 0. So we know that this is a true 0 present in age, right? Then it will be like 1 years old, 2 years old, 3 years old, 4 years old. So this how age goes on. It can't be possible that we have less than 0 age of anybody, right? So in these cases, we can say that let's say somebody's age is 4 years and somebody's age is 8 years. Then we can say that this 8-year person is twice of this 4-year person, right? Because we have 0 in it. Okay, that's why we can say that it's a twice of him. Okay, so we can say that twice of him. Okay, uh, 2 into 4, right? So since we have 0 in it, or let's say um, we have speed. Okay, speed of a car, you can say. So 0 is the minimum speed a car can have, right? It's standing, nothing it's doing. Then it can go at some speed, let's say 10 kilometer per hour, 20, then it can go till any number, let's say 200 or something, right? So now we can we have the exact difference between them? Yes, we can have it, right? So 10 minus 20, 20 minus 10 is 10 kilometer per hour more speed it does have. And since there is 0, we can say that somebody is going with, let's say, 30 kilometer per hour is let's say somebody is going 90 kilometer per hour, then we can say that he is going thrice as speed as this 30 kilometer per hour, right? So since we have the true zero, absolute zero present in this, we can have uh, multiplication division. An interval scale of measurement, we don't have true zero, right? So let's say temperature is there. Temperature is an interval scale. Okay. This two are ratio scale. This is about ratio scale. That in ratio scale we have true zero, and that's why we can do multiplication division, right? So now, so in interval scale, if I talk about an example, let's say temperature. Okay, temperature. Let's say what is zero temperature? Can I have less than zero temperature? Yes, yes, we definitely will, right? -1 degree centigrade, uh, -2 degree centigrade in let's say Russia, -2 centigrade, -3 centigrade in maybe some other country. So we definitely have -1, -2, -3, right? So that's why I don't have true zero here. I can go less than zero as well. So in these cases, I can't do multiply, right? I can't do multiply or division. I can't compare them in ratios, right? So that's what this ratio scale comes up, that we can't do ratios. We can't take ratios of them, right? But in ratio scale, we can take ratios of them definitely. So this you can see 8 year, by 4 year is 2, right? So I can take ratio because there's a ratio scale. We have true zero present, but in interval scale, I don't have true zero present, so I can't take the ratio of them. Okay, I can only do addition, subtraction, and all. Okay, and I don't have true zero in this case in interval scale. So I'll write here, let's say no true zero present, but in ratio scale, yes, uh, yes, true zero is there. Okay, so there's four kind of scales are there. So somebody had doubt what is blood pressure in this cases, right?
Yes, sir.
So okay, so see, it's a bit different. When we talk about blood pressure, it's a very different uh, thing, because if somebody is alive, okay, then only we measure blood pressure and something, right? That's how uh, the devices are being made. So so maybe minimum could be maybe 60 or something, and maximum it can go maybe I'm not sure, but let's say 200. It could go anywhere, but you can see there is no zero in it, right? There is no zero comes up in blood pressure. In pressure we have, in pressure it is a different thing. It's not, I'm not talking about blood now. I'm talking about just pressure. If then it's a different, but blood pressure is a different scale. We only measure from 60 to 200, so that's what it makes it interval. There is no zero present at this. But pressure
Sir,
is a intervals, is a ratio scale.
it's interval scale of measurement, blood
Yes,
pressure,
yes,
because there is no absolute zero.
yes,
Sir, you told about temperature. In temperature, it depends on units, no, sir. If it's in Kelvin, it can be ratio scale.
yes.
Okay, sir.
o-
Excuse me, sir.
Yes,
The phone number is in nominal scale.
yes. It is a nominal scale.
Yeah. Categorical nominal.
Yes, phone number is a nominal scale, because
Okay,
phone number, we can't add phone numbers, right? Can you do this? Can you find exact difference between two phone number?
no, no,
I mean, doesn't make any sense, right? Can you order them? Is your phone
no.
number higher than mine or something? No, right? We can't order them also. So it's just a nominal kind of data set, right? So you have to think like this, right? Can you order them? Can you count them? Can you do all of them? Like find a difference between them. Are you able to take ratios of this? Different samples in data set, right? So that's what, from there you can figure out what is the scale of measurement. Okay?
Sir, how
So
can age be zero, sir? You, you told that age can be zero.
means he never born, right? Something never born. Let's say before the birth, zero, right? So it starts with zero. He borns at the moment, then it starts, right? So that's why age. I mean, age is not exactly zero, but Zero means it doesn't exist, right? As same as speed. What is speed? Zero means it's going nowhere.
Yes, sir. It's in constant. No, it's in rest.
Yes. So that's what is all the scales. Same thing. Yeah. So that was all about week 1. So if you have any doubt in week 1, I'll I'll take it, or we'll move to week 2.
Excuse me, sir.
Yes.
Sir, I have doubt regarding to box plot questions.
Box plot is in
Week
that is
3.
numerical kind of data. Okay, so we'll cover in week 3.
Okay, sir.
Okay? Or you can post on Discord.
What, sir?
You can post on Discord.
Okay,
Do
sir.
you
Okay.
have Discord? Right? Yeah, I think right. So all have Discord.
So, excuse me, sir.
Yes.
So, can you please tell again the difference between time series data and cross-sectional data?
Yes. So time series is the data which we collect over a period of time, right? So weather data is collected over a period of time. We collect today, tomorrow, but we are collecting same thing, right? Uh, Same thing, same place, same instrument, something. All are same, and we are collecting over a period of time, right? Let's say weather data, and you're collecting about a city. That's a city could be, let's say, Delhi, right? So you're collecting about this city, and you're collecting every day. First uh, day you collected, then second day you will collect it again, third day you collected it again. So you're collecting this a temperature only, and you're collecting on all the days, right? So this is the kind of data which is time series. But if you are collecting data of different units, right? Units are changing. um, Units means there's a patients. If this data would be, this temperature is not of a city on regular basis, but about the patients, right? So what will you do? You'll have first patient coming to your this clinic. Okay. First patient coming to your clinic, you will collect his temperature. Then second patient will come, you will collect his temperature. Nothing, like you are collecting again, you are collecting temperature only. But here, what makes it cross-sectional is it doesn't matter. You are not collecting over a period, right? This patient will only come maybe once. He might come again, but for now we are not sure, right? So generally this has nothing to do with time, right? Here time is important. Which day we collected it, right? So which kind of season it's going on? It's a winter, summer. Then this whole thing will affect. I mean, in terms of temperature. So over a period of time, if you collect, then it's a different kind of analysis. So that's a time series data. And if you collect them um, on like regular basis, but don't include time, or time doesn't affect the data, that's what makes it cross-sectional kind of data. So this is a cross. Okay.
So can you explain again ratio scale of measurement?
Okay. So okay. So let's say we have some we can take, let's say height. Okay. Height is there. What could be a minimum height, or if I say something's height is 0, what what does it mean? It means that it doesn't exist, right? 0 is means nothing. uh so so that could be the minimum possible thing, and you can have anything in height, right? In measurement scale, you can take in the meter, centimeter, or something, right? So if you measure them, it would lie above 0, or 0 means it doesn't exist, right? So this kind of data sets are in ratio scale, and in this cases what we can do, we have uh, exact difference we can find between them, right? But and also we can take ratios of them also. So let's say somebody's height is uh, you know somebody's height is, let's say, 120 centimeter, and somebody's height is, let's say, 240 centimeter for somehow, right? So yeah, possible. So you can say that, okay, 240 centimeter person is twice as tall as 120 centimeter person kid, something, right? So you can say this. So this is what means ratio, that you are taking ratios of two data points. One data is of 240 centimeter person, and second is, let's say, 120 centimeter person. Then you'll take ratios of them, and that will be two, right? So in this case, it's twice height heighted than the 120%, right? So that's what makes it ratio scale. And you have absolute zero in this case, right? Because at zero means nothing. There is no height possible. Same with weights, age, marks. Zero means zero, right? You you will not have less than 0 marks generally. Okay. Okay. Anything else?
So, can you explain what is a continuous numerical variable and discrete numerical variable? Like, I don't know how to differentiate between both, and I don't think.
Okay. So continuous is, okay, let's say height is there. Okay, height of a person. Can it be 170 centimeter? Yes. Can it be 170.1 centimeter? Yes. Can it be
Yes.
170.2 centimeter? Right? Can
Yes.
it be 170 point, 2, 3, 4, 6, 5, 6 centimeter? If you can measure it, right? So you need this amount of scale which can measure it. So it could be anything in terms of height, right? So it's a length of that. So that's what makes it a continuous kind of data, right? It can be anything in some range, or it can be anything in terms of numbers, right? But in discrete case, uh, generally we have, integers in a uh, in a count, like not possible other than that, right? So let's say, but which is like, basically you can say all the uh, points are not possible. Some points are possible, then it is discrete. Okay. So let's say if you count the number of mobiles in what let's say number of employees in a company, right? That's what your count is. Let's say somebody has 200 employees, somebody has 230 employees. There's no way it's possible that somebody has 231.5 employees, right? That's not possible. You can only
Means
have discrete.
if I'm able to count anything in a point, like after that, not just 170 and 171, not like that, 171.1 as like this,
Mhm.
then only I can say it is continuous.
Yes.
Okay, in decimal expansion only. Okay.
Yes. I mean, it's not about just decimal, but you can take all the values in a scale, right? So you have studied scale in mathematics somewhere. Let's say 0, 1, 2, 3. So this is a scale, right? So if your measurement can take all the values possible in this scale, right? All the values, then
Yeah.
it is continuous. If it takes some points only, some, you know, not all of them. Let's say this 0, 1, 2, 3, 4. Then this is what makes it a discrete thing. Okay? So
Okay.
it's you have to see the scale, and then you have to think that, can it take all the values? Yes, then it is continuous. Can it take all the, no, then it's a discrete type of variable, discrete type of data. Okay,
Okay, sir.
so uh, let's move on to week 2 now.
Sir, I have a doubt.
Yes.
Sir, the topic time series data and cross-sectional data. If there is an example that there is a single day and different places, then it will come in cross section or time series.
Cross section. We already covered that.
Okay, okay.
Interval and ratio.
Sir, can we do some questions with this? If you give,
Sure.
it is good to
Sir,
understand.
please
Sure.
explain interval and ratio one more time.
Interval and ratio.
Yeah.
Okay. Okay, sure. So let's say I have some data, and I can, like, before interval and ratio we had nominal and ordinal. We can count them, we can order them, but we don't know the exact difference between 2 points. Right? So
Yes.
this exactness we didn't have. So that's why we needed something which can have exactness, and that's what interval came in. That okay, now you know the exact difference between two data points. So distance between, let's say, 1, 2, and 3 is defined, right? That will be one difference in between them. So but you can't have absolute zero in this. Wherever you don't have absolute zero, that's what is interval scale. Okay. So in this interval scales, you can count, you can order them, not an issue. You can take difference, you can find difference between them, right? That's a 3 minus 2 is 1, something like that. But you can't take ratios of them, 3/2 or something, because we don't have absolute zero in this. If you had absolute zero, you can do it, but no, we don't. It will go less than zero as well. So -1, -2, -3, all things are possible, and that's what makes it interval. But now let's say we have something which has zero in it, or it starts from zero and goes above zero anywhere, right? So now, since we have zero in it, or we know that there is no way it is going to be less than zero, so we can take ratios now, and that's what makes it a ratio scale. And we can say something is twice of, so A is twice of B, we can say that now. Okay. In case, let's say height, let's say uh, this is 120 centimeter and something is 240 centimeter, then we can say that 240 centimeter is twice of 120 centimeter. Okay.
Yes, sir, got it.
So let's
Excuse
cover
me, sir.
week 2 now, and then we'll take your all other doubts. Okay.
Excuse me, sir. Actually, I have a very little doubt. Can you please tell that stock prices will come under discrete or continuous data?
Actually, it depends on how you collect it. Generally, it is continuous data.
Sir,
It's a
under
continuous data.
Okay, so it's continuous. Or
Yes,
are
yes.
there some specific conditions where it will be considered as discrete?
There are no conditions
No, I
as
mean,
such, but
yes.
yes, stock prices are continuous, because today prices, let's say 100, tomorrow's price is 100, 1.5, maybe another day 99.87. So it could be anything on the scale of price, right?
Okay. And then,
So
sir,
that's why it's yes.
and sir, what about currency then? Discrete or continuous?
Currency is also continuous.
Okay, it is also continuous because it also does not have a fixed value, like it also changes from time to time. Okay.
No, not time to time. It will
No, I mean on yes, sir. Depending on certain factors, its value can also change. So
yes,
therefore,
it can change, and it can change to anything. Not like
yes.
you can't have, like, let's say 100, then directly 101, and then only 102 is possible. You have all the values in between possible, right? You can have 100.5, you can have 100.6, you can have 100.1, right? So all the
Sir,
possible
currency could be 120 also. No?
120 also. Yes, I mean, it is like discrete, integers are possible, right? So all the things in real number is possible in currency.
Okay, so therefore it will
From
be continuous.
positive real, basically.
Okay, sir.
All three.
Thank you, sir.
Okay. Now let's see, in week 2 we have what we have. So we know that we can. So we'll mostly talk about categorical data only in week 2. And in categorical data, we know that we can do count, and in some cases we can order them. Right? That's what nominal and ordinal data told us. So if we can count them, what we can do about it? So that count is called frequency. Now another terminology for that we'll do counting only basically, but that's what frequency is, right? So so from frequencies we'll make frequency distribution. So distribution is, you have, let's say, 3 categories, A, B, C, D, and about each category you will write the frequencies of them. Let's say A is appearing 5 times, B is appearing 6 times, C is appearing 3 times, D is appearing 1 time. So this all written here is called frequency distribution, in which we write listing, right? So listing of the distinct values of their frequencies, right? Distinct. So this is frequencies, and we are written all them distinct values of that frequency, right? So that's what makes it the whole thing is frequency distribution, right? Okay, so each. Okay. So let's see how to it's a distinct frequencies of each category, but how do we construct it, right? So first we will write all the categories. So in this is my data. For now we have 4 categories only. It could be more also, right? So here written A, B, C, D, but in reality you might have, let's say, size of cups in a coffee shop, right? So S, M, L, XL, something. So these are sizes of cups in a coffee shop. It could be, let's say, job, the job in a company. In company could be, somebody is manager, somebody is a CEO. It's one, but it's 1 or 2. Manager. Some are, team leads. So this are our categories only. But here we are, for easier example, we have this kind of data: A, B, A, B, C, A, D, A, B, D, C, something. So this all are belonging to a category, right? So now we wanted to make a frequency table of them. So how do we make them? So we count them, right? So how do we count them? So tally mark is something, we write like this, that we found one count, right? So A, yes, one time it's appearing, another time A is appearing, then third time and fourth, right? So and then we'll count how many tally marks were here, and we write that number 4, right? Same we'll do with B, that once, second time, that's what makes it 2. Then we'll do same thing for C. So C, C, so that's what makes it 2. Then we'll go for D and T, right? So that's how we got tally marks, and then we'll write total of them. So 4 plus 2 plus 2 plus 2 is 10, right? So that's what a frequency distribution. So this is called frequency distribution. So the whole thing, okay? So this box, you can maybe think of a box as a frequency distribution, where all the frequencies are mentioned of each category. Now similarly we can do same thing here. Let's say A is appearing twice, third time, fifth time, or what people do is generally, so this 1, 2, 3, 4. So that's why I mark 4 for them. Then once more it's appearing, and then you cross it off. Okay. So that's what you to remember, that this 5. Then we have one more. So that's what makes it 6. Then the same thing you have to do with B. So 1, 2, 3. Same thing with C, 1, 2, 3. Same thing with D and 3, right? So now we have 6 plus 3, 9 plus 3, 12, 12 plus 3, 15. So 15 total category, 15 total um, frequencies are there, right? So total is a total of all the frequencies. Okay, and same thing you can do for others, and you can use, of course, Google Sheet for that. So we had frequency, but there's something we can do with frequencies. We can figure it out what is relative frequency, right? So relative frequencies. So I'll write, let's say, or here itself, it's a relative frequency, right? So what we'll do is we found frequencies of each category, right? That's what we did, and then we wrote total also. The total, if you divide it by total frequency, then you'll have the relative frequency, right? It's very simple. That we found all the frequencies, right? This all we did, and then we took total of it. So now what I'll do is I'll take division of I'll divide all the frequencies by the total, right? So 4 by 10, 2 by 10, 2 by 10, and 2 by 10. That's what is a relative frequency. Very simple, very easy, right? So yes, this is what we obtained. This was our frequency table. Then in relative frequency, I'll write 4 by 10, right? Divide by total. 2 by 10, 2 is coming from here, and 10 is the total. 2 by 10, 2 by 10, and this is, it doesn't matter, but 10 by 10 or something. Right? So relative frequency will lie between 0 and 1. Okay, it's not possible that you can have more than 1 or less than 0. So minimum 0 is possible, and let's say some category, it's gonna be there, but it doesn't appear. Okay, in that cases, that kind of data is there, then you have to write 0. Okay? But generally we have all the categories which has values, which has some values. Okay, so this could be 0.2, this is going to be 0.2, this is also 0.2, this is 0.4, right? So if you sum it up, all of them will become 1 only, right? And that's what the relative frequency is. You will have the sum total 1 now. So see, earlier, what is the issue? That the number could be anything, right? 10, 20, total could be anything. Total frequencies could be in the 10, 20, 30, 40, 50, and all. So now you don't know what proportion of each frequency belongs in my data set, right? So now we can actually figure out what proportion it is. So out of all the things, we have 40%. You can say 40% of data is from A, right? Or 0.4 of 1 is there in A, right? That's what relative frequency will tell us, that how much proportion of each category is there in my data set. What is yeah, why do we need relative frequency?
Sir, can you repeat how much proportion is that? Relative proportion.
Okay, so I mean, why do we wanted to take relative frequency, and why don't we go with just the frequency? So if I have this numbers, I don't know how much, how much 4 is. What is 4 in my data set, like the whole data set? But from looking at relative frequency, I can know that this is 40% of the data, right? Let's say this another example. If I show you this, you have 6, right?
20%.
How much 6 is of 15? I mean, generally it's difficult, right? So this is 6 by 15 is my relative frequency, but I can figure it out that this is going to be also 0.4. Okay, 3 by 15 is also 0.2. Same thing, 3 by 15 also 0.2. So now I know what proportion is there of one category in my data set, right? And another great thing about relative frequencies, since you can see this both data set are very different, Here we have
Yes,
total 15.
okay.
Then frequencies are also different. Like here 4
Yes,
only,
yes,
but
ma'am.
now I have
Okay.
6 and all. But still we got same relative frequencies and proportion is same. So it just this we can say that this both data set are same only. Like they are collected in the same place, or they
Just
are
playing with
representing same thing.
numbers. Right.
Yes. So here we had only 10, but here we have 15, right? Something, right? So let's say you have two
Okay, sir.
companies where 20 employees are working here, and here let's say 2,000 employees are working. You collect data of how much they are paying to their employees, and you collect, let's say, you know here you collected 10, here also you collected 10, right? But here there are 2,000 people, right? So you have to be now how will you compare them, um, kind of thing. So you want to compare them, and then that's where this relative frequency will come and help you, that you can compare them both. Okay. So different data set, like this categorical data set, if you get of different uh, places, or same places but different time, like it was collected in some different people or something, you can actually compare them using relative frequency. Okay. So that's what it is. Since it lies between 0 and 1, they provide a standard for comparison, not just comparison between each other, like you can compare between like proportions, right? So one comparison you can do is proportion of categories. Another comparison you can do is between the data set, between two or more than two, between multiple data sets. So there's two kind of comparisons you can do using relative frequency. Okay. Okay. This is just an example. You can figure out what is frequency, relative frequencies of that. Okay. So now we'll look about something about charts, how to represent categorical data, and what can be done in that, right? So two most common displays of categorical variable, since we are covering categorical variable, are one is bar chart. So bar chart will look like this bars, right? This bars is what called bar chart. And then we have pie chart. So pie actually comes from pie only, where at each slices can be taken as a you can consume a slice. So the slices are there, and this whole thing is a pie chart, and each slice will be a proportion of it. So now uh, that this whole pie is going to be one only, right? 1 or 100% you can say, and this is going to some portion of it, proportion of that, right? A portion of it, and that's what will help you finding by relative frequencies, right? So you'll figure it out using relative frequencies. So we'll see. So a pie chart is a circle divided into pieces. Okay, so that's what we did, and it will be proportional to the relative frequencies of qualitative data. So uh, so we divided the pie into proportion of the relative frequencies, right? That's what we are will be the pie chart. Can we do that for this one? Yes, we can do that. So let's see. So let's say I have this data where relative frequency is written, and I want to do pie chart for that. So uh, okay, so this is going to be 50-50%, right? So this is 50%. This is also 50%. But I don't want that. I want 4 categories, right? So I need to divide in 4 pieces, not 2 pieces. So what I can do is I can maybe say that this much. This is let's say 40%. Okay, fine. Then uh, then I need this. The 60% is there. I have to divide it in 3 equal portions. You can maybe say, this 3 are equal portions. So this is 20%, it's also 20%, and this is also 20%, right? Or if you write the same thing in terms of relative frequencies, you can definitely do that. So that is going to be 0.4, 0.2, and 0.2, 0, right? So I divided the pie in 4 pieces, and it is proportion to the frequencies they have, right? So that's how the pie charts come into picture. You can see that the area covered by 40% or 0.4 is larger than the 0.2, right? Yes, the pie chart is used to show the proportions of a categorical variable, and pie chart is a good way to show that one category makes up more than half of the total. I mean, it could be possible, right? That you category is making more than another's, right? So let's say like this, and this is a category A, and this is B. So you know that A is dominating the B, right? And like that. So generally, when we have categorical data and wanted to compare two categories, how they are in terms of count and all, we can do it using pie chart. Okay. Then another way to represent data is we can do it with bars. We can write count on them and something like that, right? So bar chart displays distinct values of qualitative data on a horizontal axis, and relative frequency or frequencies or percentages also. Anything you can write in bar chart. But in pie chart you can't use frequencies. In pie chart, frequencies you can't. You can definitely have relative frequency. You can have percentages, because all it should end up having 1 or 100%, right? Something more than 100% pi is not possible. So but in bar chart there is no restriction. You can go anywhere. So that's why you can have frequency also. Okay. So here, what you have to do is you have to maybe you have to write on vertical axis values of something. So whatever you are measuring, let's say you are measuring count on them, you can mention that on y-axis it will be count. Let's say 1, 2, 3, 4, and 5, and something like that, right? And then uh, you will you'll you'll present a vertical bar, right, which is as a frequency or relative frequencies, a percentage or something, right? And whose height is equal to definitely frequency, right? So let's say this is 2, right? Frequency is 2. Then let's say something has frequency 3, frequency 5, frequency 1. So this all you can represent with bars. So this each box is called bar, and this is called bar chart, right? So bar chart has uh, a different aspect than pie chart. We can now, we are not constrained with the 100%. We can have anything, and we can now plot them also, like which can come first, which can come later, and all. So it's not necessary that we should always go A, B, C, D, unless it is a ordinal data. If it's a ordinal data, then we have to maintain the order. Okay. If it's not, then you can have it in any order. So since we can have any order, which is a nominal data, only nominal data can be in any order, we can actually plot them in a Pareto's way. So what does Pareto's chart is? You always choose the highest category uh, as a maybe first one. It could be B, then a little less, then little less, and little less also. So it will be in order, right? So you'll have in decreasing order fashion here, you can say, and this will be a Pareto, or you can have in increasing fashion as well. So the D, A, C, and the last one is B. B, A, C, B. So you can have in both the fashions, but it should be increasing or decreasing, right? So here it is decreasing, here it is increasing. So this both way is called Pareto's chart. And so that's what we are doing here. We are sorting by frequencies, and that's what this bars are. So bars will represent frequency, right? So what is this uh, values? How height of the bar is being decided based on frequency. Okay. Yeah. So of course you can do that. Yeah. So in okay. So in ordinal data, we can't make what we can't make Pareto chart. That is not possible. It might be possible that luck by chance or by chance we got the Pareto chart. But what we want in ordinal data is we wanted to preserve the order, right? So let's say this is my ordinal data SML, then I'll preserve this order. Or another order could be, let's say, LMS. Doesn't matter, because we don't have anything with related to LMS, which is it could be in any way, right? It doesn't matter. But the orders should be preserved. You can't have SLM. That is not how you can write ordinal data in bar chart. Okay. And then you can have any kind of bars, say like this, right? Or let's say mm, maybe like this or something, right? So any kind of bars is possible, but it should be in a whatever order the data is, right? That's what ordinal data is. You can't shuffle the orders. It should be in order. But in nominal, it's anything because there is no order in between, right? So yes, that's what.
Will it
Right?
come under Pareto charts?
Which one?
One you told right now. No, right? But because
No,
it's not in increasing order or decreasing order.
no. Yes. So it should be increase and decrease based on frequencies. They are not based on frequencies. They are based on the here the order is inherent order, right? Whatever, let's say size is like this, right? The sizes are already ordered. Like there is no relationship between like categories and frequencies, right? In this case, frequency could be anything, like I say 100, 122, 58, could be anything. But you have to preserve the order. But in odd nominal data, uh, if you have this kind of data in nominal way, then you can make a Pareto chart because you want highest frequency first, then maybe little lower, then little lower, and further lower, right? So this kind of data we want in kind of nominal way. If you represent, then it will become Pareto chart. Okay.
Okay.
Okay. So when we do graph, when we do graph the data, few things we always wanted to keep in check, that why we are drawing this. So why we need this data, right? I want to represent frequency? Do I want to represent relative frequency? Is it I'm comparing? Am I comparing two data sets? If am I, then probably putting two relative frequencies, which is pie charts, will be a better choice, right? Something. So this knowing your purpose is always required when you plot this chart. Okay. Uh, and if you can figure it out, that would be much convenient. Then you just need to write few more, think about few more questions, and you are done. You can plot the best chart, which will be not deceiving to some people. So pie charts are best to use when you are trying to compare parts to whole. So parts to whole means that's what, like one category to the rest of the category. Right? If we are doing that, then use pie chart. Bars are used to compare things between different groups. Generally, right? So if we have two kind of groups, then we wanted to plot the bar chart. Label, label your data. Yes, labeling is definitely. So we have this x and y axis, right? X and y axis. Mathematically, we have that. But here you can say maybe categories. I'm writing here, and on y axis I generally write frequency here. in bar chart. This I'm plotting about bar chart. Then you must, like, let's say, write what is this category is. So let's say this A could be B, and C some. So this all labeling is very important, right? So name the bar charts, name the slices. If it's a pie chart, then name the slices, like what does this slice represent, right? Is it a state-wise data? Is it a gender-wise data? Is it a um, size-wise data, something? So represent, what does this pie of a pie chart means, right? So a slice of pie, what does this represent? Okay. If you have omitted some of the cases, make sure to the label of the plot defines the collection um, collection that is summarized. Okay. So let's say you you remove some kind of cases, then you can actually mention them, with let's say 0 or something, right? Like that's it doesn't belong here. Like let's say this kind of thing. We had so many categories, we removed all of them, and said that, okay, uh, you know what we can have is, instead we have other. Okay, so this other is coming from all of them, right? So this thing you should do whenever you have some data, and uh, you're omitting some cases or something, you are removing, you have to mention in this, right? You can actually group them. Yeah, so this is an example of label data, that this is the pie chart, and you can see this red chart is belonging to B. This blue color pie, a blue color slice is of A. Then this belongs to D, and then you can see percentages are also represented, right? So here, like, twice it is represented, but once is fine. Like, if you have represented here, that is more than enough, right? It should be just informed that, yeah, this much percentage is there for this slice. Okay. This is about distribution of grades. So I know that what kind of pie it is. The same thing we have with bars, right? What kind of distribution of grades I am having. That so this bars are there. You can see heighted bars, and then what I'm writing, grade category. So A, B, C, D grades are there, and then we have till that's okay. That's count. It could be anywhere. So this is a labeled, good labeled data. Same thing you have with if you have many categories, what you can do is, you can actually, because at some point, like, it will become very difficult to keep um, tab of all the categories if there are too many categories. So what we do is, we have some important categories, right, which are this. How do you decide important? Based on frequency. It could be, it's not like ABCD is important. It's not based on name, it's based on frequencies. Okay. So some categories are important because they are appearing too much in the data set. Okay. Too frequent. So what we do is, we have this categories which are not frequently appearing, but they are appearing. So we group them, and then make another category, say that others. Okay. All of, and put them all into that. Okay. And this is possible. So this is a, you know like, valid way to represent data. There is nothing wrong in this, right? Now we'll see what is area principle, and we'll look into, like, what kind of mistakes you might do in area principle. So always displays the data. Okay, so display data in a fundamental rule called area principle. Okay. Uh, so this is important, that if you violate area principle, then you are kind of misleading the statistics, that you wanted to deceive something, some kind of thing. So let's see the first, maybe, principle of that uh, what you can do instead of bar chart. So this is the natural way to represent the data, right? But what you are using some boxes, and then on that you are putting some points and all, and then writing some numbers, right? And this numbers doesn't represent the bar size or width or anything. Nothing it is represent, right? So there is no baseline first, right? Baseline is 0. This is what baseline is. So there's no baseline. and the chart shows bottles on top of labeled boxes of various sizes, right? You can definitely represent data in such a way, but this is a violation of area principle, right? You should not do that. But instead you can choose a bar chart, which is, see, in this case, a Pareto chart, which obeys all the rules. You can just look at the data and you can figure out what is happening, right? So in United Kingdom, most wines are being exported, then in Canada, and least are in Netherlands. But looking at this chart, I can't figure that out very easily. I need to look into maybe all of them. Then also I might make a mistake that maybe Italy has more exports than Japan, but that's not true. I might even look like that Italy has more exports than all of them, uh, right? Kind of, it looks like that. So it could be deceiving, and that's what makes it a violated bar chart, right? You are violating some rule. Then what you can do is maybe not you, but what you shouldn't is that you should not trunk the graphs. If you do the trunk, if you do the truncation of graph, you have to do with indication. So y-axis break indication you can do, but generally you should not break the graph. So if you break the graph, here see, if I have this data which is um, breaking the baseline, right? There is no baseline in this. Like, baseline is not starting from zero. Then it looks like that this is a huge difference, right? Difference is very huge, but in reality it's not that. it, it just looks normal, right? In reality it looks normal, but if you plot this much, or let's say if I draw from here, it looks like that this W is not even appearing, right? It's just barely there, but that's not true. In reality it's far more representative, right? Here you can see it's far more representative. And so you should always choose baseline as 0. If for some cases, like the scale is going too large, you can definitely do this by representing a break in y-axis. So how do you do this? You represent like this. You can write 2 lines, and that's what it is. So here you can start that the data is starting from 8. But this is what you do when you have very high columns, like this, a very large column generally. Even if they are not, that's okay. You can do it, but you should mention it. That this mention of this 2 lines is what a y-axis break, right? If you do that, then it's fine. Now, round of errors. So this is just pretty common mistake. Sometimes people make it integer to the decimal, and they forget about that. This all summation should happen 100%, right? Or 1. But after converting decimals to integer, it might become something else. Maybe 99 or 101 or 102, something. So it can become anything, but that's a mistake, right? They should not do it. Either represent in let's say decimals, or even if you represent in integer, it should sum up to 100. Okay, somehow it should be able to sum up to 100. Okay, so don't make this mistake. So always check for round of errors. If it is there, then whatever, you choose any of the way and make it possible that all the slices are summing up to 100. Okay. Uh, yeah, okay. Yes. So that was all about the graphs. Now we have um, now let's see how to summarize categorical data. So we can definitely plot charts, bar chart and pie chart, and represent the data. But we need something which is a little bit compact. Like you can tell in words to somebody sometimes, something like this, right? So we need some compact measure of it, and that's where numbers that are used to describe data are called descriptive measure. So now descriptive measures will be introduced to you, and descriptive measures that indicate where the center or most typical value of data set lies are called measure of central tendency. So let's say your data is anything like I'm plotting bars only. So this is a bars, and in this bars, where is the typically center of this kind of data set? And you might think that okay, maybe center is here, so or maybe they're near to this chart or something, right? So or let's say okay, or let's say center is here and maybe here or something. So I don't know from exactly from the bars, but that's what we'll do. We'll figure it out the math way, right? So now we'll use the multiplication, division, something we'll use, and then we'll figure out this descriptive measures. So first is very simple. First is mod. So in mod, what we'll do is we just have the highest category, like frequency, right? Which category is highest frequency, we pick up that, and that's what mod is. Okay. So longest bar in the bar chart, of course, the widest slice in the pie chart. So if you have slice and you have widest slice, right? So that's what makes it the mod. And if it's a Pareto chart, then first category generally. So here it's being taken that it's in a decreasing order. Okay. If it is increasing order, then of course like the last bar, this will become the mod. It's very easy. You just have to pick the highest frequency, right? And be careful that mod is what category. Okay. So category is what, like something from A, B, C, or D, right? Not the frequency. Frequency is not the mod. Frequency is not the mod, but the category with highest frequency. Okay, there is subtle difference. Frequency is like numbers, like let's say 10, 20, 30, 40, and let's say this is A, B, C, D. So this 40 is not the mod. Mod is D. D is the mod because this is the category. Okay. Okay. So like you can see here, we have this all the bars, right? This what the data is. I have plotted the bar and I will pick the longest bar in this, which is this, right? You can definitely see this. So is 6 my mod? No, 6 is not my mod, but the category A, the most common category is A, and that's what is the mod. In this case, it's a pie chart, and again, you can see A has the widest slice. I mean, 40% it is including, right? Higher than any one of them. And so that's why A is the mod. Okay. It could be possible that, sometimes we have more than one categories appearing same amount of frequencies, right? So we can have pi model. In this case, this is a pi model where two categories are same. Two categories are same frequencies, then it will become bimodal. If multiple categories have same frequencies, then it will become multi-model. It could have maybe another bar which has also seven, and maybe another which is 7. So it depends on how many categories have. Since we have 4 categories only, and out of that only 2 have same frequencies, that's why it is a bimodal, but it could be multi-modal also, depends on the number of categories. So here, when we have bimodal, we say that both of them are mod, A and C. In this case, A and C both are mod. Okay, A and C both are mod. Yes. So now let's
But
see
sir,
the
B
median.
and C is not one, no? So how they are same category? B
Huh?
and D,
B and D are
not same.
yes.
So how they are different categories?
They are not same. They are different categories, right? I mean,
Sir, you said bimodal, no? Only 2 categories.
A and C are bimodal because we are A and C same frequencies, right? That's why it's a bimodal.
But sir, B and D are not same frequencies, right?
Yeah, B and D. No, we'll just take the highest. So 2 or more categories tie. So how many categories has a tie? A and C has a tie, right? Tie means draw.
Yes, yes. Very good.
Draw whatever, right? So For the highest frequency, the data is said to be bimodal or multimodal. Okay.
In whole data, only two must be similar. Those are called bimodal.
Yes, if only two, only and only two.
If more than two are, then multimodal.
Multimodal.
Okay.
Now, let's see median. So, when we go to median, can we do it for nominal data? No, we
No,
can't
sir.
do. No, right? We can't find median for nominal data, and we'll see why. It is only possible for ordinal data. Okay. Okay. It's only possible for ordinal data, and why is that? Because this, wait. So we have to do what we have to do is we have to sort the values, right? So sorting means ordering. You can say sorting is ordering the data, right? So we have to order the observations in such a way in the sorted values, and then we have to pick up the middle observation of that. So let's say yes, not let's say I have t-shirt sizes, right? So something like SS, M, L, XL, M, M, L, 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 XL, XL, it's something like this. So I'm not sure how many are there, but I have this, right? So this is not ordered yet. I have to order them, right? So I'll just first step is I'll order. So first I'll order them, right? So how will I order? I'll write from small to large. Okay? You can write from large to small, doesn't matter. So I'll write S, then okay, nothing. Then I write M. M. Then I'll write okay, M are over. I'll write L, 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 L. Then I'll write XL. L on the right. So I have same size, but I have ordered it now. So this is sorted, right? So I sorted it or ordered it, and then I have to figure out the middle value of it, right? So we'll see what happens if there is no middle value or if it's an even kind of thing. So how many we have? 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 data sets, right? So I want to figure out the middle of the 12. So what I'll do, 12 by 2 is 6. That's how you figure out the middle value. And I'll go where the 6 is. 1, 2, 3, 4, 5, 6. So this guy is 6. And if I go another side, then 1, 2, 3, 4, 5, 6, right? So this is also in the middle. So this both of them are in middle. And in this case, both are same. So I'll say that L is my median. If it would have been the odd number, then I don't need to worry too much about because any one will come in the middle, right? Because it's an even number, that's why we have this type. What if I had M and L in the middle? Let's say M is 6th place and L is 7th place out of this 12. Then what will I do? Then I'll say both of them are median. M and L, both of them are median. I'll not have any fight like okay, you both win. Okay, something. Make peace with both of them. That's what we do in finding median. Okay. So if there are an even number of observations, choose a category on either side of the middle of the sorted list as median. Okay. So you can choose either side. Okay. So but both of them are median. Okay. You can choose whatever you like. I mean, while you use something or you tell it to somebody, something like that. But we generally, I mean, in while studying, we say that both of them are median. Okay. So you can see that this is, let's say, example that 15 students are there. And their grades are listed, right? So first we'll order the data, and that's what they did. Then how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 12, 13, 14, 15. Given also, but 50. So 15 by 2 is 7.5. So from this, I know that I need to choose 8, right? Because if I choose 8, then 7. Uh, so how I know is 7 in left side. So this is my 8 point and 7 on right side, right? So this 7, 7, and this will make it balanced, right? So this is the middle point, 8th position. Okay. So I'll go and count which is 8th position, right? So 1, 2, 3, 4, 5, 6, 7, 8. Okay. So this is the 8th position, and this is my median. Okay. Now what if we had two? Sorry, we had even number. Then what will I do? First, I'll order definitely. Then since I have 14 students, what I'll do? 14 by 2 is 7. So which should I pick? 7, 8, and 8, both, right? Okay. So let's see. 1, 2, 3, 4, 5, 6, 7. So this is my 7th position. This is my 8th position. And since both of them are same, there's no clash. There's no tie, right? Nothing is there. So I'll just say that B is my median. If there was a tie, then I'll say both of them are median. Okay. If they are different category. Okay. Okay. So in this, okay, they have told us that okay, B is appearing the most, so most frequent category, right? So that's why it's a mod, and it's also in the middle also. So that's why it's a median also. So a category can be a mod and median, both of them. Okay. There is no problem with that because mod is a different kind of calculation that we take frequencies in picture, right? Here we don't care much about frequency. It should be in ordered and it should be in the middle, right? So middle and ordered, that's what we care. Shorted, let's say shorted and middle, in the middle position, right? That's what we care about median, but not, it doesn't matter how frequently it is appearing. That's not my study with median. Okay. Mhm. Okay, in this example they are saying fine. And okay, that's all. So that's all for week 1 and 2. Any doubt in this week 2?
Excuse me, sir.
Yes.
There's a question in activity 1.1 that
Mhm.
refers, there's a case given, and the options are the study is inferential but not descriptive. What does this question mean? So,
Okay, what point 1?
yeah,
Question number?
that question number 3.
Nature of the study, but then you should know. So this is the study, right? Study has been conducted to examine whether students who had applied for some exam, so MAE entrance in 2020, are willing to write the exam in the coming week or not. So I want to figure out how in next or coming week, the student will write or not, right? So a group of 10,000 students were randomly selected from the urban areas of India of the study. It is concluded that roughly 80% of the students want to write the exam. So they collected from urban cities only, right? Uh,
Yes.
that's what they did. And now see what is it? Can you say about the nature of study? Okay. So first we had population, which is all of the students who wanted to write MAE, right? All of the students who wanted to
Yeah,
write
across
MAE,
India. Full.
right? That's what my population is. But what I did is I took 10,000 students since I can't collect all of the students' data or whatever. They picked 10,000 students randomly to study, right? So since they did a sample of them, can I do descriptive study? Yes, I can do it. I can find median of them. I can find mode of them, right? So that's what descriptive. I can plot bars, charts, pie charts about them, describe them, right? Summarize them. That's what I can do, definitely. Can I do inferential study on them? Yes, right. So from them, I can do it. I mean, I'll talk about them. I try to make inference about the population. Okay.
But
Study.
isn't the study inferential because they're concluding something that they're coming or not? So is it not inferential?
Yeah, it is inferential study. Um, uh, can you say about the nature? Nature. Okay. So this exact study is, yes, it is inferential. The study is inferential, but not descriptive. But yes, this is inferential. I mean, this exact study is inferential, but I can do descriptive also. Mm, Yeah, that is correct.
Sir, I have a doubt.
Yes.
Hello?
But how can it be descriptive? So it can only be inferential, right?
So this study is definitely inferential. So this, I mean, they are okay. So I think there is a mistake in the words little bit, but I mean, it should be like, what kind of study you can do it on this, or you can do on sample or something. I mean, this you can definitely do descriptive studies on sample, and you can do inferential. Yes, there is a little bit mention in words, but this study is inferential because we are concluding about the all the students who are going to write MAE. Okay.
So
Yes.
the option 3 and 4 are not valid.
3 and 4, yes, that is, I mean, the study is descriptive, but not inferential. Uh, uh, but because let me say there is subtle just a difference of word. Because when you do this, actually this if this is the they are written like study they did on whether the student who applied will write the exam, right? That's what makes it difficult. But we definitely will do descriptive study on this also, like on sample, right? Because without descriptive study, you will not just move on to inferential. Like that's how it doesn't happen in reality. Yes. So basically, it's a little bit like words are little confusing, but that is true that this is the study is inferential only. Uh, the mentioned study is inferential only.
Yes, I chose that, but in the answer, it's showing us the study is inferential but not descriptive. So they're
But
concluding
not
on that.
descriptive.
Yeah.
Oh, okay. So then I am right. Oh, I thought.
So it's only inferential, so we can't describe. So that's why I had a confusion because if we come order-wise, we have to first see if it's descriptive, then inferential, right? Or we can go for both.
No, you can go. See, you can go for both, but uh, the studies we wanted to conclude, or we wanted to conclude that how many were going to write the exam, right, from the sample. So that
Yes.
study is inferential in nature, right? Okay, I thought there is some mistake in words, but the study is inferential.
Yeah.
But the statements the study is inferential, but not descriptive. That could be more right.
Sir, could I ask one question?
Yeah, sure.
Like if we have a series of number like 66994433, then we should find out the median. Then would be median like middle part of the number, like if five this side, five this side, and two number in between, then we add both number and divide by two, we got a median. But we can reverse that equation, and we can get the series of number like that.
Reverse? What are you reversing?
uh, just I took an example like 669944 and 33. We have a series of number.
Okay.
Okay, then we have a series of number like 12's number, like 3 times 6, 3 times 9, 3
Mm-hmm.
times 4, 3 times 3. And
Mm-hmm.
when we defined the number, then we got like middle part, two middle parts of the number, and
Mm-hmm.
we got a median. But how, after getting median, if anybody give me the median, then how can I find that this median is belongs to that number of series?
You can't figure out all the numbers of a series. You can maybe one or two, but not all. So so you should see. I mean, median is middle of many numbers, right? But let's say just median is given. Uh, First, what you are doing is you are doing on numerical data, where we can actually do divide and all something, but in categorical we can't. Right? So that's why we chose both of them as a median. So a numerical kind of study, if you have just median, let's say 5 was median, then you can't figure out all the points. That's not possible.
Yeah.
But if you have few points, let's say 1, 2, 3, 4, then maybe something like not 3, 4, but should be higher than this, right? 6, 7, something. So this 5 points are there,
Yeah.
and then maybe 1 6 is missing, and 5 was given to you. Then maybe you can figure it out that it would be 6, but they should give some more information. Like could be 5.5 also. No, what is the problem?
Yeah.
Could be something like this. They can say that it should be integer or something, right? Or it could be 7 also.
Yes.
Not an issue. So if there is something, some more information is given, then maybe you can figure out 1 or 2 points, given that rest of them are given to you. Otherwise you can't.
Excuse me, sir, I have one more doubt. Can you differentiate between structured and unstructured data and give some examples?
So structured data is something which has some, it's in tabular form, right? So rows, columns are there. That's what makes it structured. So you know what is going to come under one column, right? So you write a column that's a gender. Then under the gender column, you know what is about to appear. From the column name itself, you will know. And you kind of have the guess, right? That is what going to be there. Age, if you write age, then you know what kind of data is going to be there, right? So this is structured data. Value you put in that column, it represents a specific variable about a case, right? And that's what makes it a structured data. Another is unstructured because there's no defined rules. Like it could come anyway, like text data, right? So words are written, sentences are written, reviews are given,
So it
music.
does not have a proportionate format for
Yeah, there is no
unstructured.
format. You can't figure it out what is gonna come next or what is gonna come inside that, right? It is in a very abstract form. So that's what makes it unstructured.
Okay, sir. Thank you.
I have a question. So with regard to the bar charts, the stack bar chart, when you're talking about that, when let's say that there are two observations A and B, and there kind of any action is just 20% and 30% and vice versa. And when we try to draw a chart for this, like, should I have the x-axis still 100% to mention 100, or it's fine to stack up to cut it up to 50? Is it a right way to put it, or it's the wrong way?
Bar charts want to cut it.
I mean, the sense that y-axis I'm talking about. Let's say the percentage is only in terms of percentage I'm talking about. The actions A and B, there are two observations, and it is one is 30 and 20, other is 20 and 30. So when I try to stack one over the other, it reaches only up to 50%. So in terms of percentage, should I really show that up to in the y-axis up to 100?
Yes, because see, now we are talking about stacked bar chart, which is, you need to figure out row relative frequencies and column relative frequencies for that. So stacked bar chart, yes. I mean, no. Just stacked bar charts, no. 100% stacked bar chart is something in which case, yes, it should be 100. In just stacked bar charts, no. Then you can actually put it over one another, but you don't know what is. I mean, you have to mention very specifically what is it and how much this is representing of all the data, something like that. But that's why 100% stacked bar charts are there, which will represent the proportion of each category.
Okay, so even though just it says, as I told you, one observation was only 20% or else 30%, still I have to show up to 100 in the y-axis. Am I right?
Yes, then only you will be able to figure it out the
right
I mean, how is it associated or not? That's what our task is, right? When you want to draw the stack bar, you want to figure out association between two categories, and if you don't do it 100% stack budget, then you can't.
Okay. Thank you. And if nobody, I have one more question with regard to
sure.
the charts and bar chart and pie chart and this thing. When we are talking about that, I think there are questions which are actually saying that let's say about the area principle with the bar chart as well as in the pie chart. If I'm right, in one of the this thing as a big thing. So there, like, what are the things that are actually common to both pie chart and bar chart, and which is not common to pie chart, which we can think about when we actually cut the try to drop the wrong answer from the choices. Am I clear, or
yeah. So I mean, difference where pie chart and bar charts are different. Is that right?
So which are the ones that are the features that are common to both, which sounds same, but at the same time, when you come for the real twist that are shown in the answer. So I want to know which are the ones that I should really take care to drop those options to say this is not the one which is related to pie chart or bar chart.
So in pie chart, we can't. We can't make frequencies just frequencies. We can represent that because we need it to be 100%, right, or 1. So that will be possible with relative frequencies. So frequencies only we can represent using bar chart. The bars could be anything, right? That there is no restriction on bars. Then what could be else? in bars you can figure out the order of the data, like orders or so, like which, like let's say you can maybe write in Pareto, you can make it a Pareto, like frequency. That also you can do there. You have the biggest page. Uh, so, the slice will be largest. But if it's the ordered data, yeah, if it's the ordered data, then you'll only be able to figure it out from bar chart, and that is also not very much likely. Like if it's given, then only it's possible. I don't think so, because categories are what they represent. You should know, right? Then if you know, then what is the point of like just looking at the chart and then figuring out? No, then you can't. But so there is one thing I can say the difference is that is you can't represent frequencies in in pie chart, just frequencies, but that you can do in bar chart, not anything else.
Okay. Thank you. Because you mentioned about Pareto chart in the just now. So in the Pareto chart, it's always like the ascending to it's always from the descending thing that the case, or also the ascending is also considered.
Yes, both considered.
Order.
Ascending, descending, both considered. If it is a nominal data. If it's
Both
not
are
nominal,
considered, right?
we
Both.
will not do anything. We'll not order by frequencies. We'll go by the order of the categories, not the frequency. Right? So small is lesser than the medium. Medium is lesser than the large. Right? So there is an order, inherent order in between. So that will follow an ordinal data.
Thank you.
Anyone else?
Sir, could you please tell me how can we create a Pareto chart in Google Sheets?
I don't remember exactly. But yeah, I don't exactly remember how do you make it there. But as part of our quiz, you don't have concern about that. There will be no spreadsheet or anything to use.
Okay, sir.
Sir,
Yes.
sir, I have small conceptual doubt in week 4. Can I ask, sir?
Yeah.
Sir, in when we calculate the point by serial and we calculate the standard deviation of the numerical variable, which is x, and in question it's not given whether it's population or sample. So means whether we will take population or sample for creating the calculating the standard deviation, sir. We will divide it by n-1 or n, sir.
If it's not given.
Yes, sir. In question, it's not given. It's only in case in point
It
by
will be
serial.
given. It will be given. Don't worry.
No, sir.
Whatever it is, it will be given.
In 4.1 last question, if you'll see practice assignment, it not given.
Not given.
Not given.
Okay. Could be mistake. So we'll update that. Okay. Maybe there's a mistake in that. But it should be given. Okay. What is it? Population sample. There are no ambiguities in that. So we'll provide that. I'll look into the question, but it should be there. Okay. Whatever it's not mentioned, we'll mention it. I think there's a
Sir,
mistake
for
in that.
R, if they are not mentioning, we can understand that yes, n gets cancelled up and down. But in point by serial, they should give, sir, whether it's sample or population.
Yeah. Definitely it should be given.
Okay, sir. So, and if it's not given, sir, what we should consider?
Don't consider. I mean, I mean, this question is incorrect. Then, like, it should be made more
Okay,
clear.
sir. Okay, sir. Thank you, sir.
So one more thing, is the question paper format based on how it was given in PYQs only?
Yes. The mock test.
Yeah.
Mock test was released. Yes.
So, so it will be conducted for 50 marks, 14 questions.
Yes. 14 questions. Yes, around 14 questions you'll get, and 50 marks. Yes. 40 marks, 50 marks. Both. I mean, you that the proportion is same as the graded. It will be given in your documentation, right? T score. That this much proportion will take.
There's no negative marks for the questions.
No negative marking. Okay. Anything
Excuse me,
else?
sir.
Yes.
Sir, can you repeat the total marks for statistics?
What total?
Yes, total marks in qualifier exam.
Uh, as far as I recall, it's going to be 40 marks total. But it will be then converted to something, right? So based on your T score. I mean, not exactly 40. Like you would have seen your what do you call it?
Sir, around how many questions will be there of
14.
statistic?
Around 14. That is defined. Around
14.
13, 14. Yes,
Yes.
1-4.
Okay, sir.
1-4 questions will be there. Okay. I think that's all. Let's close this today. Okay. Thank you, everyone.
Thank you, sir.
Okay. Thank you so much.
Thank you, sir. Anyone can hear me? Hi. Can